So, what's in an atom? Well, it turns out that atoms have parts. Okay, they are the smallest unit of matter, and yet they do have parts. So, J.J. Thomson, and I'm not going to quiz you on these guys' names, but they did some amazing things, and so we at least, continue to remember them. I'm not going to quiz you on dates either, but it's interesting to realize, okay, this was discovered, he lived between 1856 and 1940. So this was quite a long time ago. He discovered a smaller particle inside the atom that we now know as an electron. The electron is negatively charged, and it is much smaller and lighter than atoms. Obviously, it has to be smaller if it's part of an atom, right? Electrons are uniformly present in many different kinds of substances. So it's not just that a gold atom had some electrons in it, but they found electrons in everything that they were able to look at. So he proposed, based on this discovery of this negatively charged particle, that there must also be something positively charged in there to balance the charge, because they could tell that atoms were electrically neutral. Atoms don't have a charge. If it's got a negative particle in it and it's neutral, there must be some particles too. So Thomson had a model of the atom, an idea of what the atom looked like, and it's called the plum pudding model. Okay, he was British. Here in America, we don't eat plum pudding. We think, why would like chocolate pudding with plums in it? Ew. It's more like a blueberry muffin. Okay, it's more like a bread cake sort of thing with plums in it. So we'll just think of blueberry muffins. So the idea here is that the atom is like a blueberry muffin, and the electrons are the blueberries scattered randomly throughout it. And the bread part, the muffin part, is just this sphere of positive charge. They didn't know what it was like, so there's this positive charge, and then there's these electrons sprinkled through it. That's the plum pudding model. Well, so he proposes this, and other people are like, okay, that's really interesting. Let's see if we can find something that shows that's not true. Or let's see if we can confirm that. So Rutherford set out in 1909, and I believe he was actually trying to confirm Thomson's model. So he did this experiment, and it's really pretty interesting. So he took a very thin piece of gold foil, really, really thin, and he shot alpha particles at it. Now, alpha particles are really, really tiny particles. They're actually helium nuclei. They're very small. So he's got this source here, and he's shooting alpha particles at the foil. And what happened was really interesting. They were able to detect these because they've got this detector around here, and when the particle hits, it makes a little glow, and they're able to record that. What they found was that most of the particles went straight through. Like, we're shooting particles at a solid object. The particles are going straight through. Some of them went at a little bit of an angle, and some of them bounced back. And that was really, really crazy, that they're bouncing back. This led to the discovery of the atomic nucleus. Because what did they expect to happen? Well, the model they were testing was this plum pudding model, where you've got these electrons and this charge, this positive charge. They were expecting those particles to go straight through, and most of them did. What they didn't expect was that some of them would bounce back. What that told them was that there must be something inside there, and it must be pretty massive, relatively speaking, that these particles are hitting and bouncing back. So there's something small, because most of the particles are going through, but there must be something in there that they're hitting and bouncing back, because otherwise why would they come back?
Mrs. King.
Yes?
What did end rather than lead?
The lead is because alpha particles are a form of radiation,
Okay.
and so you don't want them escaping all over the place because they're hazardous.
Okay, so that
Yeah, sometimes they put, that was just containing them. They sometimes put details in there that I'm not sure why they put them in there because it's not very relevant, and sometimes it's more confusing to get these details. It's a good question. An interesting thing that Rutherford said about this experiment, he said the results of this experiment were as surprising as if you had fired a cannonball at a piece of tissue paper and it came back and hit you. That would be surprising, wouldn't it? A cannonball at a piece of tissue paper, and it comes back and hits you, and you're like, how is this possible? That's how shocking this discovery was. They really thought they were just going to go straight through, and they didn't. So this was, just a really big discovery. And based on this, Rutherford came up with the nuclear theory of the atom. So a different model, a different explanation for how the atom is behaving. And most of this is what we currently believe to be true. Most of the atom's mass and all of its positive charge are contained in a small core called the nucleus. So the nucleus is here in the center, and that's where all the positive charge is, and most of the mass. And most of the volume of the atom is empty space, through which tiny negatively charged electrons are dispersed. So the idea of the little tiny negative electrons being dispersed was still present. And obviously there was a fair amount of empty space because most of the particles went straight through. But in the middle, there's this very dense thing. And that must be where the positive charge is, and that would explain why these particles are bouncing off. The negatively charged particles are equal in number to the positively charged particles. And the positively charged particles are called protons. Protons are positive. They both start with P. Protons are positive. So if you have 5 electrons, negative charges, you have to have 5 protons for it to be neutral. Now, in this picture, this is not to scale at all. But here they're showing the nucleus, and there's protons, and also another particle called neutrons. The neutrons are neutral. They don't have a charge. Neutral neutrons, positive protons. I'm sorry, electron doesn't start with an N, but it's the other one. That's the negative one. And the electrons are out here. So just to give you an idea of how small the nucleus is. If the nucleus was the size of a pea, a green pea, like your mom made you eat, and you put that on the 50-yard line of a football field, the edge of the atom would stretch to the goal lines on each side. And in between is mostly nothing. I mean, it's just crazy. It's absolutely crazy.